Welcome to the Deep Dive, a weekly dose of breakthroughs, curiosity, and connection. Because the future is better when we build it together. Our mission for you today is to really pull apart the biggest, most impactful ideas from the sources you shared. We're going to be connecting some grand philosophy to some very granular engineering. We're diving into this revolutionary concept of Spaceship Earth. We'll cover a triple threat of hydrogen energy advancements, analyze what looks like a self-driving bonanza, investigate some incredible robot skin-to-surgery milestones, and try to figure out what the real fuzz about space actually means for us.
And you know, what ties all of this together, and it seems like a lot of disparate topics from particle physics to energy, is this underlying principle from Richard Buckminster Fuller. He wasn't really interested in just fixing symptoms. He believed that real, enduring change comes from designing fundamentally better systems. I mean, systems that are so efficient and harmonious that the old, broken ones they become obsolete.
Okay, let's unpack this with his most powerful metaphor, which is Spaceship Earth. It's a concept that really hits you the moment you see that iconic image of Earth from orbit. It's just one protected national park, one closed system with limited resources. And the scariest part, there is no instruction manual.
Exactly. And Fuller saw all of humanity as the crew of that closed system, operating what is, arguably the most complex machine ever built. He wasn't an alarmist, though. He stressed that the system itself wasn't inherently broken. It was just being managed in this really fragmented, inefficient way. The solution for him was whole design, a way to integrate every piece of knowledge, every sector, every viewpoint into a single, cohesive, working model.
And when you look at the sources detailing the essential spaceship crew roles, it makes our current priorities so clear. You've got the engineers right. They're responsible for redesigning energy and infrastructure to cut waste, to achieve more output with less material, or what Fuller always called doing more with less.
Then you have the scientists and the navigators. The scientists are, reading the instruments, mapping the climate, learning the system rules. And the navigators are tracking the long-term planetary boundaries, the risk factors, making sure we don't accidentally sail this thing into a cosmic iceberg.
You also need the crew maintenance roles. The medical officers tending to our bodies and minds, which is so essential for long-term health and psychological resilience. And then the agronauts and ecologists managing life support by restoring soil, water cycles, basically making sure the ship can feed itself indefinitely.
It really just highlights the radical interdependence required. Every single role is essential, and every improvement compounds, which is why I think the sources quote Woodrow Wilson here. He said, "We must neither run with the crowd nor mock it, but try to offer thoughtful advice to it and to ourselves." It's a call for collaboration, not chaos.
And the final sort of physical product of this whole design idea was his Dymaxion map, which was just revolutionary because it broke every single convention. It wasn't north up. It wasn't centered on any specific nation. And when you fold it, everything touches. The continents meet.
The oceans connect. It completely removes that idea of above or below in terms of, power.
But the real power of the map comes from the layers you put on top of it. It goes from being a static map to a dynamic systems diagram.
Right, we're talking about mapping energy flows, global food systems, carbon sinks, water cycles, even infrastructural connections like ley line cables, and this is the fascinating part, those peace vectors.
Peace vectors. That's a term that we should probably unpack for the listener. What did he actually mean by that?
Well, he wasn't talking about military zones or conflict lines. A peace vector for Fuller was a resource-based global infrastructure that when you implement it, it eliminates the cause of conflict. So, for example, creating a super efficient, globally distributed clean energy grid is a peace vector. Why? Because it removes the strategic need to fight over dwindling localized fossil fuels. It reframes the world as this living circuit where feedback and balance are actually possible, driven by abundance, not by scarcity.
That reframing is the key. Okay, so let's move from this whole system philosophy and the latest specific breakthroughs that prove this approach is actually working on the ground.
Precisely. If Spaceship Earth is the design challenge, then we have to focus on its most critical fuel source.
And here's where the engineering gets really interesting, starting with, the origin of the universe, hydrogen. Our sources detailed this spectacular trifecta of three major breakthroughs that all happened almost at the same time.
And this is more than just, small progress. This is the kind of convergence you need to make hydrogen a real global competitor to fossil fuels. The historical challenges have always been production, storage, and then industrial scale demand. This trifecta basically addresses all three.
So walk us through them.
Okay, first, There's a new liquid system that can store sunlight and convert it directly into hydrogen on demand. This solves that age-old problem of intermittency. What do you do when the sun isn't shining?
You store the energy as stable hydrogen fuel. That handles storage and utility.
Exactly. Second, we saw the world's first gas turbine designed to run entirely on hydrogen, not just a mix. So existing power plants can be adapted to run cleanly. And third, and this is maybe the most foundational, is the ability to do million-ton scale steel production using hydrogen instead of coal.
Wow, that is a staggering industrial shift.
Mm.
Steel is one of the toughest nuts to crack for heavy emissions. If you can clean up the steel supply chain, you dramatically reduce the carbon footprint of, well, everything. Every building, every car.
It makes the old method instantly obsolete. A perfect example of Fuller's principle. It hits heavy industry, the power grid, and energy storage all at once. It's coordinated systems thinking in action.
Now, switching gears a bit, from planetary energy to advanced computing, we saw a fascinating development in material science, a new intelligent material that computes through its physical dynamics, not through transistors.
Right. This is a huge leap toward neuromorphic computing, mimicking biological brains. The advantage is efficiency, speed. A normal computer separates memory from processing. This new material integrates sensing, memory, and computation into the same physical structure. The computation literally happens in the material as it changes.
So instead of a separate CPU crunching data from a sensor, the sensor is the computer. It processes information through physical reaction.
Which is incredibly promising for robotics. And speaking of instantaneous processing, that mind-car connection is getting very real. Beyond Neuralink getting ready for high-volume production, there's new research exploring how a passenger's brain signals could help a self-driving car make safer choices.
That's a truly sci-fi concept. So instead of just sitting there, the car might use ambient human input, maybe passenger stress levels, to smooth out its decisions in tricky traffic.
It opens up huge new data streams for the safety models. And those models are already delivering some impressive stats. I mean, the shift in autonomous transportation is well underway. We're seeing scaled Waymo deployments, Tesla Cybercab plans, and even a successful coast-to-coast drive using Tesla FSD without a human stepping in.
The pace is just relentless. One analysis of Waymo data even forecasts an 80% reduction in traffic injuries in the U.S. once these vehicles become the standard. That statistic alone is world-changing.
It is, but let's pause on that 80% number. To get there requires more than just better software. It needs regulatory acceptance, public trust, a massive infrastructure shift. It's a total system redesign.
Which brings us right back to Fuller's philosophy and the power of policy. Our sources point to Norway as the ultimate case study in rapid transformation.
Exactly. Norway's market for electric vehicles is just extraordinary. Nearly all new cars sold there are electric now. It proves that when policy, incentives, and infrastructure are all designed holistically, you can reshape an entire multi-billion-dollar market in under a decade. The system can change if the new model is just better.
That's the goal of whole design. Okay, let's transition from maintaining the spaceship to maintaining the health of the crew.
Right, and before we get into advanced robotics, we should probably anchor ourselves in the fundamentals. Harvard's timeless habits for health, quality sleep, movement, balanced nutrition, social connection, and stress management. Simple inputs, profound impact.
And when maintenance requires intervention, we need the most advanced tools. Let's talk about that new breakthrough in neuromorphic artificial skin.
This is so exciting because it addresses a huge limitation in robotics, the lack of refined sensation. This new material mimics human tactile perception. It's neuromorphic, meaning it's designed like a nervous system, integrating sensing and computation into one flexible material instead of having separate sensors wired to a central computer.
So the robot hand can feel pressure and texture and process that information instantly, locally, without latency, just like a surgeon's finger.
Precisely. And that's exactly what you need for delicate tasks like surgery, and we're already seeing the application. Surgeons in Kuwait recently did a robotic surgery using instruments guided by real-time control systems. The robotic arm is moving from being a rigid tool to a sensitive extension of the human will.
And speaking of healing, what about internal repair? There was a new understanding of how to restore damaged tissues by reactivating dormant regenerative pathways.
This is huge for the future of healing. Most complex organisms, including us, lose a lot of our regenerative capacity as we age. We just rely on scar tissue. Identifying how to turn those ancient pathways back on. It opens the door to restoring fully functional tissue, not just patching damage. It's like finding the system's factory reset button for cellular repair.
Looking ahead, it seems like health trends for the near future will be shaped by more progress in gene therapies, CRISPR, and new heart and stem cell treatments. Also, metabolic drugs revealing unexpected benefits beyond weight control.
And in our own notes for this deep dive, we had some fascinating threads for you to pull on, suggestions that really broaden what we even consider medicine, specifically keeping a close eye on cell development research, especially Michael Levin's work, the rise of consciousness healing tech, broadening the scope for therapeutic sound and light, and a suggestion to consider more reliance on plant-based medicine over the standard pharmaceutical kit.
That last point requires a real shift in mindset, doesn't it? It means seeing our bodies and environments as interactive systems, not just a collection of parts you can fix with isolated drugs.
Absolutely. It connects right back to that Fuller idea of comprehensive understanding. He said, the more we really learn about big patterns, then the more comprehensive we are. It's about aligning our practices with nature's own operating system.
Okay, let's talk about the biggest operating system there is, the universe. We're moving to the highest scale now, starting with a management change at CERN. Mark Thompson takes over in 2026, and his main goal is to push forward with the Future Circular Collider, the FCC.
The FCC is the successor to the Large Hadron Collider, and the scale is just monumental. We're talking about a particle accelerator ring that could be 100 kilometers in circumference.
What's the driving ambition behind a project that massive? I mean, what are they hunting for?
Well, the goals are nothing short of monumental. They want to deepen our understanding of the standard model, sure, but crucially, they're hunting for the physics that lies beyond it. This includes definitive searches for dark matter signatures, unlocking entirely new physics. It's literally a multi-billion-dollar attempt to find the universe's instruction manual, the ultimate knowledge for the Spaceship Earth crew.
That's the largest scale of design we can imagine. Bringing it back down to orbit, though, we also highlighted that pretty cool development of a space-based factory that can generate plasma.
It's more than cool. It's functionally critical. In a vacuum, in microgravity, materials behave differently. Generating plasma in an orbital factory allows us to process materials, maybe create ultra-pure alloys that are just impossible to make on Earth because of gravity, and it has huge implications for new kinds of propulsion and energy systems in space, too.
Which brings us to the philosophical question of why we keep looking up in the first place. The sources asked, what's all the fuzz about space?
And the answer provided was profound. It argued that space exploration goes far beyond economics or geopolitics. Its fundamental value is anthropological. When humanity zooms out to see Earth from space, it's forced to zoom in on its understanding of itself.
That view changes everything.
It does. Seeing the planet as a single, fragile sphere just strips away all the artificial divisions. It forces us to confront that our fragmented models for politics and ecology are just inadequate for managing a closed system. As the saying goes, as above, so below. The cosmic view provides the clarity to redesign our planetary operations.
And that ties right back to that core design philosophy from the start. Fuller said, you never change things by fighting the existing reality. To change something, build a new model that makes the existing model obsolete.
The FCC is a new model for physics. Autonomous vehicles are a new model for transport. Hydrogen, a new model for energy. And seeing Earth from space, that's the perspective you need to build a new model for global governance.
So after covering everything from hydrogen to robotic skin, particle physics, and a literal cosmic perspective, the core takeaway here seems to be that continuous, challenging call to think in terms of wholes.
So what does this all mean for you listening? It means choosing to be deliberately expansive instead of contractive in your thinking. It means asking, how big can you truly think? Because what we're seeing is that the bigger the thinking, the more lasting the solution. A small fix might last a year, but a whole design solution can last generations.
And we'll leave you with a few threads to pull on, sourced from our own internal notes, just to encourage your own curious self-discovery.
Instead of setting traditional resolutions, maybe try a curious self-discovery path. Map out your personal systems and goals in a more holistic way, like Anne-Laure Lecomte suggests.
Also, take a deep dive into the future of food. It needs a full system redesigned, covering everything from precision fermentation and alternative proteins to regenerative farming. Our food system is one of the most fragmented systems we run, so it's ripe for a Fuller-style overhaul.
And finally, just for a moment of lightness, look up the photos from the Mars Reconnaissance Orbiter. They show these distinct, heart-shaped geological features on the Martian surface. Even when we zoom out to the largest scale, that human tendency for connection persists.
And remember Fuller's powerful call to action that guides this entire mission. We are called to be architects of the future, not its victims. Thank you for diving deep with us. We'll catch you next time.